Applications of differentiation. First derivative test, practice A. Find all local maxima of the function f of x, given that f prime of x equals x minus 1 times x minus 2 times x minus 3 times x minus 4. Notice that in this question, we're not actually given what f of x itself is. However, we don't need to know. In order to be a local maxima, we have a couple conditions. First, we need the derivative f prime of x to be equal to 0. But second, let's analyze what a local maxima looks like. Well, it's a point that's higher than all the other points in its neighborhood. So, as seen before, its derivative is clearly 0 because the tangent line is flat. But more importantly, the first derivative is positive because the function is increasing going into the function, and decreasing slash negative coming out of the function. So we also need this derivative to obey a change from positive to negative. We'll keep that in mind. Now let's do the question. It's clear that as f prime of x is a product, the only way it would ever be 0 is if one of those terms itself is 0. This corresponds to x being equal to 1 or 2 or 3 or 4. Now we need to find which of these obeys the positive to negative switch. Let's draw the number line and evaluate what the derivative looks like on each interval. Well, we see that if x is less than 1, then x minus 1 is negative, x minus 2 is negative, x minus 3 is negative, and x minus 4 are negative. The product of all four negatives would be positive, so we can put a positive sign there. Similarly, if x is between 1 and 2, notice that now x minus 1 flips to positive, but the other three stay negative. Well, now I have the product of three negatives, which is negative, and a positive. Positive times negative is negative. We can now notice a pattern here. Every time I move one interval to the right, exactly one of these four terms is switching from negative to positive. For example, between 2 and 3, x minus 2 is now positive. When this happens, the whole product switches signs, which means that if I know that the interval from 1 to 2 is negative, then it switches signs from 2 to 3, positive. From 3 to 4, it'll be negative. And 4 and onwards, it will be positive again. Well, now we can finish the question. We need positive to negative swap, which means that this happens at 1 and it happens at 3. So those are the two answers. Looking at the solution, it uses the first derivative test, which we outlined before. First, we needed the derivative itself to be 0, and second, we needed the sign change to specifically be from positive to negative. Once we had that, it was easy to see that the only possible solutions would be 1, 2, 3, and 4, but after that, we had to actually make sure that the sign change was from positive to negative. To do this, we listed out the sign on each interval. We used a shortcut in our solution using the fact that the sign has to keep changing because exactly one of these four terms will switch from negative to positive. Once we had that, the only solutions were 1 and 3 because only they had a positive to negative switch. From there, we were done.